Next. My name is Stephanie Barger. I'm the Director of TRUE, Market Transformation and Business Development. Along with our other colleagues with the TRUE program, we are excited to host this webinar. We are going to have two great speakers that are going to talk about decarbonization and zero waste. I think that's something that's very important. I like to say zero waste is sometimes the stepchild or the forgotten part of sustainability, yet our products and materials and packaging are some of the most critical to helping decarbonize our world. And more importantly, there's valuable resources and money that can be saved and made. We'll have a short Q&A at the end. So once again, please make sure that you're putting in your questions in the Q&A or through the chat. And then after this webinar, we're really excited. We're going to have some breakout sessions to give you the opportunity to network with one another. Next. Our first speaker is Sue Beets-Atkinson. Sue has been with TRUE since the very beginning and actually helped develop the program. She works with SBM Management as their Global Vice President of Sustainability and has led many companies to get their TRUE certification. Next. Our second speaker is Grant, and he's with BioCo Tech America. And I like to call Grant our professor of composting and greenhouse gases. And he will really do a deep dive into our program and what we're looking at when we're trying to decarbonize and reduce our greenhouse gases. And with that, I'll introduce Sue Beets-Atkinson. She is our first speaker. Sue, go ahead and take it away.
Thanks, Stephanie. Hi, everybody. Thank you for the opportunity to share. I think this is a new topic, and it's interesting on many levels on how we look at decarbonization and what's involved in it. So I thought we'd start out with what is the definition? And it really is to reduce or eliminate carbon dioxide emissions from the process, such as manufacturing or the product of energy. Biomass will certainly play a role in decarbonization in the economy. And the word decarbonization refers to all measures through which a business sector and or entity, a government, an organization, reduces its carbon footprint, primarily in greenhouse gas emissions, that's carbon dioxide and methane, in order to reduce their impact on the climate. So very briefly, what is greenhouse gas and how is it measured? And I put some information in here about the different scopes. Scope 1 is emissions under direct control of an entity. The natural gas used, your vehicle fleet, stationary diesel combustion, refrigeration, air conditioning at your facility. Scope 2 is emissions associated with your electricity generation and use. And scope 3 is just a menagerie of different things. It is depending on how you set up your carbon disclosure project or greenhouse gas tracking, you identify what exactly is in your scope 3. And it really is a mixture, whether that's solid waste report, generations from vendors, employee commuting, there's many layers to this. And then scope 1 and 2 are the ones that are most commonly used, easiest to measure, they're quantifiable. Scope 3 becomes very difficult because you have to be able to identify what your measurement is, how you're tracking it, and then all the different entities that comprise it. So we wanted to talk really about methane and waste. And I'm going to tell you right off, working with businesses especially, they are always looking at oil and gas, electricity. They never look at waste. And we've really been focusing on this with our customers because anything that is waste coming out of their building has a measure of methane. Whether I put that in the landfill, and I'm going to show a slide in a minute about how that breaks down, or if I look at food waste, what happens if I put food waste in compost and it goes into a compost yard and they don't capture the methane from that? versus I look at putting that food waste into a landfill, and now you have more gases, but sometimes those are captured. So it's very convoluted, it's very confusing, but we want to just really focus on the waste part of this. And about 20% of all human-related methane is from the waste product, and you can see that hierarchy on this graph. So how waste supports decarbonization. So it's a perception thing. I just talked about energy and water. They have the largest footprint. It's probably true with that, but they focus on that as a business to try and make change. Waste has a smaller footprint, but does it really? I mean, look at everything that we put in compost, recycle, landfill, and that has a cost associated with it. It also has the gases that come from it. And you've got to identify how far it's driving, because that's an important part of all of this. Now, methane is a short-lived climate pollutant with 84 times the impact of carbon dioxide, and that's over a 20-year time frame. So it really has an impact on what we do and how we communicate. And I think that's a large part. Grant's going to talk to that in a little bit more detail. But if you look at landfill gas, and this is where we start, if people don't put things in the right container, right? You've got your 3 streams in an office building, but if they still put things in the landfill, that's a missed opportunity. We are generating more methane and more carbon dioxide just because they don't understand what goes where. Important part of this. But you can see how simplistic this is, that the methane is really strong around food and garden waste. So we really need to be making sure that we're tracking that. The other thing that we've looked at is, how far do I have to drive for something? Now, years past, there was a study done that said, even for food waste, the farther you drive, sometimes it is better than putting it in the landfill. And there's a balance that has to be found with that. But we really want you to take into account that some of your material is still going to landfill. And we need to know that that has gas. In some instances, they're captured. In other instances, they're not. And so I really wanted us to focus on transportation. You know, depending on who your waste hauler is, depending on not only your waste hauler, let's say it's Waste Management, Republic, Recology, whoever that is, what kind of trucks do they drive? Do you require in the contract what they drive? So very important to know what kind of vehicles they're moving your materials in and how far away things are. So we actually did a case study at that very, very large technology company up in the Seattle area, because we did some work on what kind of trucks they were. We did the math around, is it a diesel truck or is it a compressed natural gas? And then we had to look at how many miles to the landfill, how many miles to the transfer station for recycle, how many miles for the compost, and even construction and demolition. And so it's very important that you've got so many different things that you're going to have to try and figure out, or at least keep it simplistic to look at the mileage, types of truck, and how can you look at a better program? How can you enhance your zero waste program to make sure that it's going the shortest distance with the best outcome? And that's on all of us to look at how that process works. So I also wanted to circle in the circular economy, because all of this feeds into it and helps us support the direction that we're going. So if you look at redesign, so I'm looking at food waste. And when I look at that, this large company that we did the case study on, it's 73 miles each way to their compost yard. And then they cover it's Cedar Grove up in the Seattle area, and they cover with a Gore material, and they're trying to capture the gases. So that's good. But is there a better way? Is there a simpler way? Is there a way that we can make sure that we're capturing all of that food waste, as well as landfill and recycle? So we're always looking at how do we do a better job. So then we look.
Hey, Sue, you muted yourself.
Sue, I believe you're muted.
Okay, there, better? Can you guys hear me? Okay,
yes.
Thank you. Sorry about that. So circular economy, And it's all zero waste, right? It's redesigning what you're doing. Where do you generate it? Can you use durables instead of compostables? All of those things are going to create a waste item, whether you are diverting it or not, and you can track that outcome. Then you're looking at reduction, and then your reuse, and then what's left in that diversion program. And my ultimate goal is to truly eliminate the diversion part of things, because I've managed it better at a higher end. So reduce and reuse. You need to understand the difference between these and how it will transform the market, because that's a critical part of that operation, and tracking it, because you don't want to change your diversion program through that either. Loosely, it's almost like a scope 4 with that embodied carbon, because you're looking at the life cycle of what you've changed things to, what's involved in the processing in it. And durables are always better than anything that has that carbon, as long as they're being reused over and over again and they don't disappear. So we want to push beyond the waste part of thing, the diversion, and really look at decarbonization. So one of the things that one of our clients did is really focused on all durables. Now, there is an extreme that happens when you put too many things out and you're using too many dishes. But this client really went to the effort of, coffee cups, water cups, bowls, plates. Everything is durable in these, as well as their silverware. And there's ways that you can actually track that data and quantify the meals sold by an average, and work within your service provider for food waste, especially to be able to calculate this. And as Stephanie mentioned, not only the weight, but also the dollars. Now, these dollars do not include any labor for washing dishes, but we really looked at the savings associated with either buying disposables or compostables, and then also the weights associated with avoided disposal cost. And that's a critical part. If you're not tracking that, you should really look at that to say, simplistically, if I landfill something, it might be $500. If I compost it, it might be $400. If I recycle it, it might be $200. And that avoided distance between recycling or composting over landfilling will give you that quantifiable numbers to help you with your program. And it shows true savings. Other things to look at is, how do I eliminate items out of a break area? We know that we see a lot of creamers, so can you go to the pump? We also know that during COVID, a lot of problems with going back to disposables, everything had a wrapper on it, etc. It's time to move away from that and get back into more recyclable items. Or this is a different machine that you actually have sugar and all your different sugars, creamers, whatever, and they're put in there by bulk. So it's not, small packets, it's very large bags that are put into this. So it's a different way to think about the waste that is generated and how you eliminate those things, because this is going into a landfill. It's going to create a gas byproduct. And so lastly on this is really looking at food waste. Is there a way, does your vendors on site go and work with you to eliminate the food waste? Do you track that? Are they reusing products from, hamburgers into a soup the next day? And then how do you communicate that? And how do you really focus on getting those items out of a landfill? You can't just set up a program and walk away and assume that it works, because it doesn't. It takes constant communication and educating people. So transforming the market really makes a difference. We've got to look at how we generate the waste, what's involved in the waste, and really looking in that scope 4 of embodied carbon, life cycle approach. Durables make things better. You want to account for that and start tracking the numbers. And there are quite a few websites. WARM is one of the best options through the EPA, sort of start your quantification. And so in closing, you want to do it right. Don't generate it. How do we look at that? So make a decision to make change. Take it in pieces. Don't try and change everything at once. Look at food recovery. Eliminate that food waste stream if you can, and identify exactly where it's going to. Constant training of them and reinforcing the fact that we don't want food waste in our landfill. Use equipment and technology and do it right. Don't generate it. Thank you. With that, I am going to hand this over to Grant, and we're going to do questions and answers. Please put them into the either chat or the question and answer section, and we will answer those when we get done. Here you go, Grant. Thank you.
Thanks, Sue. Hi, everyone. So yeah, that was a great presentation, and sort of sets the stage for how we dive a little bit deeper into these things. So some of the quantifications, understanding, some of the things that Sue said, just, below the surface. So I use sustainable as a more general term. I think us in the environmental world get pigeonholed into this meaning something that has to do with the environment. When I use the word sustainable and sustainable decision making, I mean that holistically, as we'll move through this. So what I'll talk about is different carbon molecules and their effects, something that Sue mentioned as well in short and long term carbon molecules, as well as some of the quantification tools. And then we'll jump into GHG protocols, and then sort of a case study in putting it all together. So the first thing I want to talk about here is that once we create carbons, they have to go somewhere. And I want to mention that we talk in CO2 all the time. And in reality, we're not just creating CO2s. We're creating a whole bunch of different molecules with greenhouse gas potential, and namely CO2, N2O, and CH4. So the biggest thing here that I want to talk about is short and long lived, where carbon can be, between 100 up to 1,000 years to have its global warming potential, whereas methane is about 12 years. And Sue mentioned, I think it was 84 times as potent, but that number becomes really interesting when you actually start looking at the math, which is the bottom calculation here, is that when we talk global warming potential, and emissions factors and all these things, we're usually talking about a 100-year timeline. So if a CH4 has its global warming effect in 12 years and carbon in 500 years, we're talking hundreds of times more potent as a greenhouse gas than is CO2. And I think it's important for us to keep that in mind. The rhetoric is about CO2s, but when we're creating these things, it is important to understand that there is a difference. And for us to sort of start going the other direction, I believe in a lot of the empirical evidence suggests that targeting some of the short-term molecules is going to, have a lot better effect for us in the short term. So with that, I'm going to turn to some of the quantification tools. And funny enough, we have to go back to CO2 equivalencies in order to talk apples to apples. So emissions factors are used pretty much in every type of quantification. They're used in GHG protocols, they're used in the WARM model, the SURF model, and they allow us to compare all sorts of emissions just directly. So anytime you produce a CH4, it's going to give you the theoretical global warming potential in CO2 equivalencies. And an example of that is also something that Sue talked about with hauling. So the type of truck matters, the type of fuel being used matters, the area that you're in matters. If you go for the electricity side, right, it's not just how many kilowatt hours you're using, it's where are you getting those kilowatt hours. So the carbon content of the fuels that you're using for energy. There's also other ways to do it in the waste sector, which is converting, basically what would turn into a methane if it was to go into landfill. And then on the negative side, there's carbon storage in the soil. And these can help us inform decisions on impact. So they really give us a way to say, hey, this project is going to give us this much benefit, whereas this other project is going to give us 10 times that benefit. And to go a little bit deeper, especially in waste management or materials management, there's mainly people are using the EPA WARM model. The SURF model is not as widely used out of California, but it does do a good job of breaking everything down into very small pieces. So for now, we're going to focus on the WARM model. And it's easy to look at it sort of from a top down and not break things down, but I think it's actually really important to understand each variable. So you have DFL, RMA, TC, you have the CO2 that's coming out of your compost process, you have M&Os and SCS. And I think something that Sue said that's really important is that TC cost, right? You have a certain amount of mileage, and the emissions from hauling the waste can actually outweigh the benefits from diverting from landfill. And you can see that in a mathematical equation, right? If TC is, basically a higher negative than DFL, then you're sort of in trouble. And you can go through these and break down each variable and get a pretty precise model. Luckily with the WARM model, if you're using just on the EPA's website, it'll sort of give you some placeholders for, a generalized type of fuel with a generalized mileage, but you can go in and change those to give yourself a more exact number. And then as far as, what you're getting as far as a benefit, obviously we know that storing carbons in the soil is a really great outcome. So then you say, okay, well, just diverting it from landfill is great, but if you look at the numbers, the negative in the soil carbons capture, so a good thing, a good negative, it's actually just as impactful as it is from diverting it from landfill. So it's sort of a double benefit. And that's why I have the critical thinking blurb over there is aerobic versus anaerobic, or compost versus a sludge product. You have to look at those things to make sure that your entire model is giving you a net benefit. And then lastly, the influence of that CH4 conversion, because all of these models are using a generalized form anywhere from 20 times to 100 times more potent for CO2 versus CH4. But like I showed in that calculation, that can be a lot more drastic. So I have this up here so everybody understands the models that we're using, and I'm going to use this going forward just as an example. And then the other tools that we have at our fingertips are the ones that we've seen for every other project that we have in business. And I think it's really important to understand the economic viability of each project. I think in sustainability, it's really easy for us to just focus on impact, and in a perfect world, that might be the case. But these projects need to have push behind them. They need to get done. And I think that these calculations allow us to do that. So for instance, with waste hauling, if you convert that to on-site, then you're eliminating your hauling cost over time, whereas you have a sort of a fixed cost for whatever machinery you're using. And over time, that project's going to pay for itself. And it gives you just a whole myriad of pieces of information that you can use to base decision making on. The last piece that I want to go into before we go into sort of putting this all together is that scope is a very interesting subject in that it seems very set in stone, but at the end of the day, the entity that's reporting is actually the one that's deciding where each emission goes. So these things aren't set in stone necessarily. And a lot of people will suggest that step one with scope is just defining your boundaries. Where does your operation end and the third parties begin? And obviously there are some pros and cons to placing an emission in each scope, as far as how much data needs to be shared, the reporting, how accurate it is, all of these things play in to where you want to define your emissions. But I think it's really important to understand that it's not necessarily set in stone. It is a little bit arbitrary at times to understand these things. So for instance, what we're going to go into is that on this slide, waste disposal is a scope 3 because you're paying somebody else to do that for you, basically. But if you were to bring that on site, technically it would be a scope 1. So now I'm going to sort of put this all together. There's a lot of numbers on this slide, but basically what this is doing is taking everything I just talked about and putting it all together. So your economics, your impact, everything is in one place for you to see. And this particular example is diverting 65 tons per month of food waste by composting it on site in an aerobic in-vessel composting system. And what this allows us to do is say, okay, well, we're spending this many dollars on this project, and that project is responsible for a theoretical impact of X MTCO2e per year. So then we can go down and we can compare those right side by side. And I think what's really interesting and something that Sue's mentioned and something I hear a lot around waste management is we are sort of the stepchild. And that really shouldn't be the case given the numbers. This example in particular, if I zoom in on some of these metrics, you can see the impact per dollar here is extremely high with in-vessel. And that can be the same with compost hauling as well. Obviously depending on each of the different variables and the TC costs and all of that. But you can see that even compared to solar, we have a much higher impact. Something I forgot to mention, you can standardize this either direction, right? So you can standardize it on saying, I want this impact, or you can standardize it by saying, I have this much money to spend on sustainability in general. And so if we're spending the same amount of money, this is what we're getting with each of these different sustainability initiatives. And then we can go further than that, and we can say, the cost for each metric ton of CO2 equivalents reduced is X. And then you can compare just that one number between all sorts of different projects. And then once you have these numbers, then you can go back over into scope and understand, okay, where does that lie? Because I think one of the other reasons why waste management is a little bit aside sometimes is because it is usually a scope 3. So if we change that to scope 1, it becomes a lot more prevalent and sort of in the forefront of our minds. The other thing about that is that our data for waste disposal or materials management is very accurate. We know exactly how many pounds or how many totes or how many gallons of recycling, of food waste, of landfill waste. We know all of those things. So it's actually a pretty easy metric for us to account for, which makes that scope 1 emission pretty easy to put in our end of the year carbon accounting. So basically we're taking all of these things and then making decisions. And I want to touch on a couple of these. I mentioned sort of at the beginning of this that in a perfect world, impact is our driving force, and it still should be. But it's not all that it takes when you are making a decision. You have to understand feasibility, you have to understand, the long-term goals of the company. But I think for waste management, something that I see and I hope others see is that it really is hands-on. When you convert, a solar cell into energy, and then that goes into your lighting system, a little bit difficult to see, and you don't really need a ton of buy-in from all of your stakeholders. Whereas if you take, a 64-gallon tote of what we call waste, and you turn that into compost, which is this lush, usable product, and you put that on your land, I think that you can start seeing this tangible nature of sustainability. You get a lot more buy-in from the people who are engaged in that operation. And then again, something I just touched on with the regulatory compliance, because it is a little bit more tangible, it's a lot easier to report. So I think when we make these decisions about decarbonization and how we're going to get these done, it's important to dive in, because we do have a lot of theoretical models that can give us information on which is going to be the most impactful, which is going to allow us to get this done. How am I going to sell this to the people who are writing the checks? And, is this in line with the long-term goals of our company? And once you have all of those things together, we're making decisions that, A, can go into place, and B, will have, the largest impact over time. So with that, I will pass things back to you all.
Great. So Holly's going to solicit some questions. There's a few that came in from the audience, and I'm going to try and join from my computer. So Holly, take it away.
Sure thing. Hey there, everyone. My name is Holly Griffith. I'm the product manager over on the True side. Stephanie's having some technical issues, so I'll be filling in as a quick Q&A facilitator. So please, if you have any questions for Grant or Sue, please pop them in the chat. We'll just kind of host for as long as we have questions. And it looks like we've got one for Grant. Do you mind elaborating a bit more on the differences between the warm model and California's CERF? Does CERF work for outside of California?
Yeah, so I'll answer that in sort of two ways. The SURF model is a lot more detailed. So it's similar to going down the rabbit hole of the emission factor and seeing, each different product. So in the SURF model, you have each variable broken down quite a bit more. So it just gives you sort of a more accurate representation of your program specifically, and more ability to, get into the nitty-gritty. At the end of the day, usually in practice, the SURF and the warm model come out with, a per ton estimate. Basically, that's what you're trying to get to, is if I divert a ton of waste from landfill, how many metric ton CO2 equivalents is that giving me? And so it's just level of detail. But as far as compliance goes, the warm model is much more accepted. It's just used more. It's been more empirically validated, and it's kind of the gold standard, and honestly much easier to use. And that's probably why it's used more. But they both get you to the end metric that's the same, and usually they're within a pretty negligible difference in that end metric.
Wonderful. Thank you so much. It looks like we've got another one up here that's seems like you spent a lot of time with these numbers, and kind of curious about what you're seeing as some of the most consistently impactful or cost-effective decarbonization options in the waste space.
Yeah, I mean, I can say this very unbiasedly. I want to be biased because I know that I have it in my head towards waste management. And no matter how I mess with the numbers, it's always the most impactful per dollar is waste management. Whether that be composting on site using a composting hauler, given that it's a small transport. The projects they're more manageable because they can scale, right? You can have large or small scale. They're usually not insane dollar value projects, and it's for the dollar, you're creating the most impact caveat there, LED lighting, by the numbers, do it first. It's LED lighting is the low hanging fruit for sure. But after that, it's waste management in all sorts of ways. And we can go into that at some point, and anybody's willing to, you know, send an email with specific questions. But usually when we're doing these, waste management comes out on top.
Fantastic.
could-
And yeah, please do.
Thanks, Holly. I think the difference and where we've got to figure this out is how do we get that communication up to the management, to the facility teams? You know, we know that almost every business is really focusing on net zero, you know, net neutral, net negative on their carbon. And I think from what we've seen and working with Grant with a couple clients, they just don't know any better. And somehow we've got to be able to communicate to the management of the changes that can take place. And in some instances, it's not going to a compost yard because that's the easiest place. It might be looking at a piece of equipment and having it on site and doing a ROI and identifying, you know, what's the cost neutral on this? Not only just the dollars, but also that carbon breakdown. So I think that's important for us all to be sharing and learning from this is, now, how do I take this from listening to two people speak about it to making this work for my operation?
Yeah, and just to elaborate a little bit, you know, when we're talking about different sustainability initiatives, you know, we're talking in the entire range of things that you can do. There's a whole lot that goes into these calculations. So EV charging, for instance, is a big one right now for a lot of people trying to make an impact. And you say, okay, how do we quantify that? And the answer is, you say, how many vehicles or how many miles am I replacing by putting this EV charging there? And then you have to say, okay, well, how many hours is that EV charger being used? And then you have to say, what is the average person driving? So you have to put all of these things into a picture and then get down to that CO2e. So there are some nuances to understand exactly what's right for each customer. But if we're using generalities, waste management is kind of the low hanging fruit here.
Wonderful. I think, Stephanie, you said your Wi-Fi is back up. Do you want to take the next couple questions? Oh. Okay, perhaps not. I'll keep going then, and just let me know when you want to tag in. So let's go ahead and do this lower one. Grant, what platform were you using for data visualization?
For data visualization?
That is, I think, for the slides and kind of the images that you had, what kind of platform were you approaching it with?
So the one that said sort of putting it all together, that is an Excel that I built. That the actual math behind it is all warm model and emissions factors. Everything is published on the EPA website. So all of the data, you know, it's something that's interesting, and I've had this response before, is that, wow, how did you get those things apples to apples? And it's just taking emissions factors and creating one metric to compare against each other, and then putting a price at it, throwing a price at it. And you can make that theoretical or actual by saying, okay, I have this project and this project, here's the price, here's the theoretical impact, and then you kind of go from there.
Wonderful. I'm seeing, how do you ensure, and this can probably be for both, but how do you ensure compliance? What resources are out there to kind of do that work?
Grant, I'm gonna let you start.
To ensure compliance, I mean, it's tough because a lot of these metrics are difficult to capture. It's not like we have a dome and there's a little thing on the top that's collecting all of your emissions. So within waste management, it's actually arguably a little bit easier because you have a bill that you can compare against, and you know where that's going, and then you can use these theoretical calculations to do your carbon accounting. Now, how you're going to be audited is a whole nother question, But
Mm.
I think the onus is on, at least for now, the onus is on the entity who's doing the reporting to be responsible and do the best that they can, because everything that we've talked about thus far is theoretical. There are tools out there, but I can tell you that they're insanely expensive to get any sort of monitoring tool that's giving you real readouts. But by my knowledge, and don't quote me on this because I can't give any sort of advice on that for each individual, but it's do your best, use the data that you have at hand, and then use the tools to calculate from there.
I think what we did is we used scales. We started out with the actual weights. So an example is we have a digester at this large client, and we would weigh everything and take the tare weight of the tilt cart out of the equation. We got to the point where we did QR codes, so the person scans it, puts a weight in, it automatically takes the tare weight out. When the material came out of the machine, because we're getting a reduction of almost 73% at this one facility. So everything gets weighed again. So the output is getting weighed so that we now know, we put 100 pounds in, we got 27 pounds out, and then we can start figuring the gases out on that. The other way that we did that is also by mileage and, rudimentary Excel to say, here's the mileage, here's the types of trucks, here's how far they have to drive each way, how long do they sit in traffic, because that's an important part of things. It's not just a direct 73 miles. If anyone's been to Seattle, it is not a 73-minute drive. It is like an hour and a half each way. So you've got to sort of build things and put your assumptions in there so that you can quantify and document. And normally, if you get audited and you can show those assumptions and where you got your numbers, and a weight ticket, a scale, all of those things, I think they really help with us being, whether you're doing an audit of your waste program, whether you're doing an audit of your greenhouse gases and how you track it. That helps.
Fantastic. Thank you both so much. Our next question is, I'm super new to True. As a True advisor, are there methods to also measure ESG scopes for clients?
They're definitely not in the True advisor per se, because ESG is environmental social governance. It's everything of your business. It's human relations. It's so many different layers with ESG. I think our part of True is in how we quantify. And I think that what True does is goes beyond just your diversion and takes it and looks at what's your reduction. What are your numbers associated with reduction? We don't always take it to the level of that life cycle analysis. That's currently not as a part of True, which I think could help if somebody really needs to get into that level of nitty gritty. But what is the impact of that? What is the value of going to that level? I always try and balance what I'm trying to achieve versus how deep I can go into that spiral hole. And I can spend 10 hours on it, or I can spend 100. So it's just that balance. Grant, you want to add anything?
No, I think that's good. I mean, I think your main point there is that when we talk about ESG, that's, it's similar to CSR, right? Like this goes into CSR, right? But it's so big that it's difficult to say one way or another. I think that you start at the bottom. You start in the things that you can quantify, the things that you do have metrics for that you can be very confident in. And then you kind of move from there to, sort of larger holistic goals.
Wonderful. Thank you both so much. My next question, and I think this one's going to be for Grant, is could you share the sources of your data?
Yeah, so the data that I shared on the putting it all together, all of that is just off of the EPA. The emissions factors are all on there. The deck itself, the Excel calculator, so to speak, is proprietary, but I can share the sources there. The easiest way to get those is honestly just going onto the warm thing that gives you all of the comparisons, and then you can click how did we get these, and then it'll give you the emissions factors for each piece of that. And then as far as the costs goes, so to get down to the cost per MTCO2e, those are based off of, you know, averages that can be changed here or there. That was just a placeholder given average costs to do those different projects in the United States. Obviously, those can go up and down depending on where you are.
Wonderful, thank you. And this one kind of leads into the same space, but a little bit more specific. So if no one has an answer, that's also okay. But kind of how can bioplastic end of life emissions be accounted? So how would we approach it with bioplastics? I've gotten parentheses from a landfill scenario, and then kind of if there's a factor that can be used to do that calculation.
Stop generating them.
Yeah.
5%.
I'm a Sue, and I don't want to get up on my pedestal here, but bioplastics are tough. They don't really compost in any, even if you're really doing a job of composting, they're still not composting. And then you take into the full life cycle of things, like how was that made? So that's more of a scope 4 thing. Scope was, Sue is kind of talking about that a little bit, which is really hard to quantify. So the answer is no, there is no factor that you can just throw at that, but it is, you can do it, right? You just have to know where it was made, and then you have to track it all the way through its life cycle. But there's a whole myriad of issues with bioplastics. One of the ones that I think is most compelling is that it looks like a recyclable. So a lot of times it goes into the recycling, and then that's a contaminant for your recycling, which is a tough one. But as far as the actual breakdown of that product, it takes a very, very, very long time. However, if you are doing that in an aerobic environment, and if you are aerobic, you're always going to CO2 rather than CH4 based on thermodynamics. So it will break down in the correct way over time. It just takes a very, very long time to do so.
That makes sense. Appreciate the answer. I've got from Mary Alice. Grant, I saw in your graphs that in-vessel composting provides a lot of GHG reduction values compared to other sustainability programs. Curious if you also have a comparison between in-vessel composting and regular windrow composting.
Yeah, generally speaking, they are similar. So again, I've talked about earlier, you're trying to get to that last number, which is each ton I divert from landfill, what is my total impact of that? And so with in-vessel, you're on site, right? So you have basically zero TC. Your transport cost goes to zero because you're not hauling. So that at the end of the day increases your impact. The other piece of it is M&Os, and basically the intermediaries and CH4s that you're getting through composting. And every single composting environment will have an aerobic state somewhere, meaning you're always going to create some sort of methane. But the more often you turn, so basically the more controlled your environment is, the less intermediaries and the less CH4 you're going to have. And so, basically the more your mass, when we talk composting, the more your mass is aerated, the more it's in an aerobic state, the less CH4 you're going to have. So as a metric, that means your M&Os are going to go down. And then from there is, the compost that you're creating. And that for these is a huge number. I sort of blew past that a little bit in the presentation, but when you break down the WARM model and you look at even the placeholders that they're using, your carbon storage is a gigantic number. So that is the use of the compost, and that remains constant for traditional windrow and in-vessel. So there's a couple little differences there, but compost hauling also has really high impact numbers when you put those in.
Wonderful. Thank you. I've got one last question in the chat, and this one I'm not as familiar with. So if either of you have insight, I read somewhere that new modern landfills are designed to minimize emissions by incorporating layers deep into the land. Do either of you know if this is accurate?
Number one, how many modern landfills are actually being built? One, I don't think there's any. Two, I don't have an answer. Stephanie, do you happen to know that?
Yeah, I think the thing is, thank you, both Sue and Grant and Holly. Just quickly for this question, I think what's important is, yes, we have improved the landfills, and we have, plastic lining to keep it from leaching to the water table. We're capturing the methane gas, but it is still not perfect. And so there is still a lot of leaching of the material into our water tables and creeks and rivers. Even if they're capturing methane, there is still quite a bit of methane that just escapes. And then plus just the litter problem. If you've ever been to the Orange County, California landfill after a Santa Ana wind, what blows out of the landfill, even though they're doing everything they can to cover it. So it's kind of like what we said before, we can't depend on landfills to solve our problem. So yes, we don't need the open landfills like many of our developing countries have. We need to help them. But landfills are not a solution. And I say that with all due respect to the engineers that are out there designing them. But, you're handling huge amounts of waste. And it's very, very hard to control. So that was a longer answer. Grant, do you want to give anything to that? And then I'm going to kind of wrap up the Q&A.
Sure. Yeah. I would just say that all sort of these capturing things, of which there's quite a few. There's two things that you have to understand. One, a lot of it escapes. Two, the mechanisms by which you take whatever was captured and you reuse that is much more complicated than using compost. So you have to get that back onto the grid, let's say. And so there's a whole nother part of this process. Like, okay, we're capturing, let's say 80% of it, the 20% is still pretty bad, but then what are we doing with that? And what is that perpetuating, and where does that fall in the life cycle of things? Is that creating electricity? Is that going into some sort of biofuel? So you kind of have to look at what they're doing with the end product. Whereas with composting, the answer is you're putting it into the ground.
If I could, I think the other thing with all of this is knowledge, right? So if you're a business, and I have a client that we've done a waste analysis at, and if I know that 70% of my landfill is recyclable or compostable, I need to focus on that. I need to stop that going into the landfill, because I'm putting food waste in food waste containers that generate all of those greenhouse gases into the landfill instead of the right mechanism. And so it's almost getting back to the basics of knowing what I generate, where I put it, where the people put it, because that's the bigger problem, and how we can look at that as a starting point. And then you can look at the level of detail behind what's happening with your food waste and how do you handle that and what's the best decisions to make. So my 2 cents.
Great, thanks, Sue and Grant. I'm going to add a couple of more notes to our decarbonization talk before we end this. So I think the other thing which we have talked about is purchasing and really being inclusive in everything you're purchasing. A simple example is when you reduce paper, most people only think about the paper reduction, but you're also reducing toner. And so from a financial standpoint, at least from one of our companies, when they reduced their paper, they saved $1,000. And yet when they went back and looked at the reduction in toner, they saved $3,000 on toner. So you have all that upstream production of toner and all the packaging that comes with your paper and your toner, and then the reduction of not having to ship it away, even if those things are being recycled or refilled. The other thing that really started this conversation, and Sue went into it, is, you know, we were talking with our colleagues at Toyota, and with all of their supplies coming in, they get tracking from FedEx, UPS, USPS, all the different companies that are bringing materials into their facility, how far they're driving, what kind of fuel, all of that. But we realized in our, I like to call it materials management versus waste management, our materials management, we're not tracking it going out. So Sue really emphasized that, and I think that's what's really important. I would encourage you to definitely with composting, to lean on the U.S. Composting Council. They have many, many amazing resources and a lot of incredible advisors. So it's a really great organization, even if you're not in the United States. And that's also for the EPA WAR model. Anybody can use the EPA systems, even the EPA portfolio manager, no matter where you are in the world. So we will share those links. And so we really want to do that. And then, you know, composting is my favorite way to decrease our greenhouse gases. And that's why we call it re-earth. And I think that's what's really important. It's not about just getting it out of your trash and get it composted, but the reason we're doing this is we need to get it back to our farms, back to our forests, back to our communities and our lawns and gardens. We have depleted our soil so badly, which encourages, you know, petroleum-based fertilizers. We have to overwater. So we're going to share a link for the Moraine Carbon Project, because if we get organic compost back to our farms and our forests, it grows the soils at multiple rates versus just the dead soil that we currently have. And so that should be a huge driving force. And of course, then we could sequester greenhouse gases by having this organic soil, and then by growing trees and everything else. And that's the bigger picture that we want to look at, and how, as we all know, nature is tied together. So we're going to get ready to end this part of the webinar. And I just want to thank Grant and Sue so much for sharing their knowledge and wisdom, and also the challenges. So thank you. This is the first of probably many webinars and talks on decarbonization. We really need to dive into it. Santiago is going to share some sites now and some great resources. And as he's bringing it up, we will now end this part of the webinar, but please stay on for the next part.
Thank you.
Great. So great. And we have some more people in the waiting room, so we can stop the recording part of this, Santiago. So once again, just thank you, not only to